All right, this first section is asking which of the following methods would provide a valid conclusion. So a valid conclusion means like nothing affected the results. So it could be who you ask, how you ask, where you ask, and stuff like that. So the first one is a uniformed police officer interviews a group of high school students. She asks each one his or her name and if he or she used an illegal drug in the last month. So is there anything that's going to affect how the students answered? The answer to that is probably. So that means that we're not going to get a valid conclusion. So what could affect how the students answer? Well, the fact that they're asking for their name and whether or not they've been using the illegal drug in the last month by a police officer. Students might be inclined to lie. Okay, second question. A survey about quality of food in the cafeteria was conducted by having forms available for students to pick up at the cash register. A drop box for completed forms was available outside the cafeteria. Now this one right here is probably not going to provide a valid conclusion. Why is that? It's because when things are voluntary, you usually get like extremes. So for example, if someone isn't satisfied with the food in the cafeteria, they might actually take the time to go and do the survey because they think that it's going to create change and they'll maybe get some better food in the cafeteria. So you might get, extreme opinions and not everyone's opinion. So it has to be more random than that. Maybe every fifth student that walks out would make that a better scenario. Okay, next. Extensive studies on coronary problems were conducted using men over 50 years old as the subjects. This one is probably going to be another no. And the reason why is because it might not just be the men over age 50, and it's not good to just generalize to any other age or any other gender groups. So the fact that it's so specific isn't going to, talk about these coronary problems for everyone else. So that's not a good one either. Number 4, every student was handed a unique number as they walked into the classroom. The teacher used a random number generator on their calculator to display the number 1 through 40. If the student's number was picked, then they answer the question of the day. Okay, so I'm just going to give you a huge hint here. The fact that they use a number random generator means that this is good. Anytime you have a random sample or students are picked randomly, it makes everything valid. So anytime you see a random number generator, it's an automatic yes. There are no issues with the way that question was asked. Number 5, survey every third senior that walks into the government economics class on what they believe the senior gift to the school should be. So this one, every senior takes government or economics, and the fact that you're going to survey every third senior that walks into those classes, that's totally random, so that's another yes. Okay, number 6, Mr. Casper decides he wants to find out how the students at Thunderbird feel about math. He decides to survey his AP statistics class to answer that question. Now, if you think about that, there could be a couple of issues wrong with this one, so I'm going to put no for a valid conclusion on this. First, the fact that the teacher is asking his own students about how they feel about math. Students might think that there's a grade attached to that, and if they say they don't like math, that Mr. Casper might lower their grade, so they might not be truthful. The other thing is who he's asking it to. He's asking the AP statistics class. Usually people who take AP classes are more inclined to enjoy those classes and be better at those classes, so they might have a better opinion about those classes. So there's a couple of issues with that one. Number 7, an advertisement by Ford about the Ford Pinto claims it is the safest car ever built. Are there any concerns about this study? Yes, it's a study by Ford about Ford. Now the issue with that is they might not be truthful because they're trying to sell. It's their company and they're probably just worried about profits or something like that. So they might not always be truthful. They might look for the positives about the Ford Pinto to show that it's the safest car. Now, if this was an advertisement by a third party, like not Ford, then it would probably be a little bit better, but this one's going to have to be a no. Number 8, Santino wants to determine the most popular teacher in high school, formulate a question that will get the most accurate responses. So you just got to be careful on how you word it. If you're going to ask the question that's going to cause people to lean towards a certain teacher, well, then that's not going to be good. So you just keep it simple. Formulate a question that's going to get the most accurate response. Would be something like, who is the most popular teacher in high school? So it doesn't, sway anyone towards one particular teacher. I'm not going to write this stuff down. You can just listen. So it says Allison wants to get new snack choices at the student-run store. Formulate a question that will get the most useful responses. Again, what snack choices do you want at the store? So it's very basic stuff. You just don't want to influence them in any way by how you ask the question. Number 10, over the past few years, there's been a strong positive correlation between the annual consumption of diet soda drinks and the number of traffic accidents. Do you think increasing consumption of diet soda drinks causes traffic accidents? And they want you to explain that. So, I mean, it could be a number of things that's causing this pattern to happen. For example, what if there's just more people? So if there's more people, then there's going to be an increase in the number of people drinking diet soda. And if there's more people, there's going to be more traffic. And so there could be more traffic accidents. So there could be some underlying causes, true causes for this correlation. Over the past decade, there's been a strong positive correlation between teacher salaries and prescription drug costs. Do you think paying teachers more causes prescription drugs to cost more? So again, there could be some underlying facts here that could be causing both to happen. For example, there's a thing called the cost of living. And so, for example, if you were to live in the 50s compared to living in 2020, the cost of a house is different than the cost of a house now. So as the prices go up, the prices of everything go up. And so that could be the underlying cause for this pattern. Number 12, over the past 50 years, there's been a strong negative correlation between average annual income and the record time to run 1 mile. Do you think increasing incomes causes decreasing times to run the mile? So if you think about that one, kind of like we talked about in the last one, the cost of living or inflation. Inflation could cause increasing incomes, but the decreasing times to run the mile could be caused by the fact that you're just training more. So I mean, if you increase incomes, it doesn't really cause people to run the mile faster or anything like that. It's their training. So there's no connection other than the fact that there's a pattern, but they're not the true causes of each other. 13, a study shows that there's a strong negative correlation between increased minutes of exercise and occurrences of juvenile diabetes. So do you think that increasing childhood exercise could cause decreased juvenile diabetes? So this one, there actually is a connection between those. It has been proven that increasing your exercise decreases the chances that you'll get diabetes. Okay, and then we get into the math part of this. It says find the mean and median. So the mean is where you have to add up all of the numbers. So I'm going to pull up the calculator here. Let's clear out all this mess. And then we're going to do 8 plus 7 plus 5 plus 10 plus 6. Oops. Make sure you type it right. Plus 8 plus 7. 1, 2, 3, 4, 5, 6, 7. There's 7 numbers. 1, 2, 3, 4, 5, 6, 7. So if I add those up, it's 51, but I divide it by 7, and I get 7.28. And I'm just going to round it to like 7.3. Now the median is going to be the number in the middle. Before we figure out what the number in the middle is, we got to put them in order. So it's 5, 6. See, I'm going to cross them out as I go. 7, 7, 8, 8, and then 10. So to find the median, we eliminate the extremes. So we work from the outside in, and the number is 7. Now, if there was 2 numbers, we would add them up and divide them by 2. Okay? The next one is pretty much the same. So the first part is calculator work. So we're going to go ahead and add this stuff up. So let me clear that out. 4 plus 28 plus 30 plus 35 plus 55 plus 42 plus 37 plus 35 plus 40. So the sum is 306, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So I have to divide that by 9. So anytime you find the average, you add them up and you find the total, and then you divide by how many there are. So that's going to be 34. The median, again, you put them in order first. So I'll do this across the bottom. 4, what's next? 28, I think. And then 30, 35, there's 2 of those. 35, 35, 37, then 40, 42, and 55. So we're going to cross them out from the outside in. So 1 on the left with 1 on the right. And again, there's 1 number left. If there was 2 numbers left, we would add them up and divide them by 2. But the median on that one is just going to be 35. Okay, next one. Glendale Union randomly sampled 10 of its freshman girls to determine the average height. So think about what average means. Average means to add them all up and divide it by how many there are. So they want to find the average height of freshman girls in the district. So the sum means that they've already been added. So it's going to be the 650 for all the heights added up. It says, what's the best guess on the average height? Well, we know there was 10 girls total. So when we add up these numbers, the number added to 650. So all we have to do is take the 650, the total, and then divide it by the 10 people. So there was 10 numbers. That means that the average height would be about 65. Okay, next, when we have this normal curve stuff, all of this normal curve stuff is it's just related to the percentages on the inside. So it says what percentage of a distribution is included from 1 standard deviation. So 1 standard deviation means away from the middle. So if this is the middle, 1 standard deviation would go 1 to the right and 1 to the left. Now the only way, actually I didn't read the full question, so let me start that over. It says 1 standard deviation below, so that means 1 line to the left, and then 2 standard deviations above. So if this right here is my center, or my average, then I would go 2 to the right from that, so go 1, 2. So we would basically add up all of the percents in between those 2 boundaries that we created. So it's 34 and 34 and 13.5. So 34 plus 34 plus 13.5. That would be 81.5%. It says what percentage of distribution is included from 2 standard deviation below the mean to 2 standard above? Well, that's nice. So this is the middle, that's the average. 2 to the left would be here, 2 to the right would be here, and if you look, we can just look at these percents down here, and that's a 95%. So the answer is just 95. If a certain population has a mean of 40, so mean of 40 is the average, and averages go in the middle. So we would stick a 40 right here. And then it's standard deviation of 5, so that means that this is 45, 50, and 55. And then over here we would have 35, 30, and then 25. It says, what's the probability that a randomly selected item will be between 45 and 55? So we've got 45 here, we've got 55 right here, so it's everything in between. So we add up those 2 numbers, 13.5, 0.5, and 2.35. Oops. 2.35. So it's about 15.85%. If a certain population has a mean of 35 and a standard deviation of 5, what's the probability that the randomly selected item will be between 25 and 35? So the mean is the middle, so we put 35 here. Standard deviation is what you're going to count by. Standard deviation is 5, so this would be 40, 45, 50, and then 30, 25, and 20. And I forgot what the boundaries were. The boundaries were between 25 and 35. So 25 is here, 35 is here, so we just count and add up the percentages in between. So we got 13.5, and we're going to add 34% to that. So that answer would be 47.5. I'm going to clear that off because I need it for the next question. forgot what the number was, 47.5%. Okay, next question. What happens to experimental probability as the number of trials increases? Make sure your answer includes the name of the rule. So, as your experimental probability increases, no, I said that wrong. As the number of trials increases, then your experimental probability approaches your theoretical probability. So what that's called is basically called the law of large numbers. The more you do it, the more it's going to approach what should happen. So your trials, the more you do them, the more accurate it becomes in terms of approaching the theoretical probability. We already did that one. Okay, Mr. Guruli and Mr. Casper want to determine whether a six-sided die is fair. Mr. Casper plans to roll the die 30 times and record the number of times it comes up with 5. Mr. Guruli plans to roll the die 150 times and record what number comes up each roll. Explain who is using the better method and why. Okay, so this is tied into that last question. I know most of you are like, I don't want to roll it 150 times. 30 times is easier. But the thing is, the more times you do it, the more accurate your number becomes. So who is using the better method? Mr. Guruli. And the reason why is because of the law of large numbers. The more time you do it, the more your experimental probability approaches your theoretical probability. And again, I'm not going to write all that stuff down. Okay, it says determine if the situation represents an observational study or an experiment, and then explain your answer. If it's an experiment, identify the control group and the treatment group. It's a bunch of mumbo jumbo. Okay, so you are sitting at the mall and you want to know if during the summer people tend to wear flip-flops. You organize the shoppers into two groups. One is the group with flip-flops and the other group is not. Well, you're not really interacting with the people, you're just kind of watching, so that's going to be an observational study. Number 24, it says, it is rumored that a water bottling company sells water that may cause people to develop high blood pressure. To study this, scientists give this water to one group of lab rats, and then the second set of lab rats receive tap water. So that's going to be an actual, the experimental. The control group is the tap water group, and the treatment group is the bottled water group. Number 25, scientists want to study the risk of developing lung cancer. One group is non-smokers and the second group is smokers. So again, they're just going to sort of, they've got the two groups, but they're just going to kind of watch and see what happens over the course of time. So that's going to be observational because they're not really controlling anything, they're just watching. Number 26 says a company wants to measure the effects of fertilizers on plants. One group is the plants that receive sunlight, water, and fertilizer, and the other group is the plants that just receive sunlight and water. So again, that's going to be experimental. The control group is the sunlight and water group, and then the treatment group is the group with the fertilizer. Okay, in a study of 1,600 people, 75% said they go to the grocery store once a week. The standard deviation is 2%. What is the margin of error for this survey? Determine the interval that is likely to contain the percent of people who go to the grocery store once a week. So your margin of error is actually pretty easy to calculate. What you do is you take your standard deviation and you just double it. So your margin of error is going to be 4%. Your confidence interval comes from adding and subtracting that 4% to that 75% that said that they would go to the grocery store. So the true number should land somewhere in between 71 to 79%. So that would be your confidence interval. You could say with 95% certainty that the actual number is somewhere in between 71 and 79%, 95% of the time. So again, the process is really easy. You take your standard deviation and double it. That's your margin of error. And then you take that margin of error and you go to your percentage and you just add that amount, so plus 4, and then you'll also minus the 4. And that's how you get these two numbers right here for the confidence interval. Number 28, the World Health Organization has determined that the heights and ages of male children between ages 5 and 19 is approximately linear with the best fit line of y equals 2.14x plus 28.3, where x represents the age in years and y represents the height in inches. It says, what's the predicted height of to the nearest inch of a 7-year-old male? So age is x. So when they say 7 years old, that means x equals 7. So you're just going to plug that into your calculator, into the formula that they gave you. So in the calculator, we've got 2.14. You're going to go times 7 plus the 28.3. They're going to want this to the nearest inch because this is all in inches. So we are going to say that this is 43 inches. And the reason why it's 43 is because it's 43.2. 2 is lower than 5, so we just cut it off. What's the predicted height of an 18-year-old male based on the best fit line? So again, we will just use that same equation, and I can just go up and change the 7 there. So we want an 18-year-old male. So we'll put in 18 instead of 7. And this would be 66.8 inches, so we'll say that's about 67 inches. According to the line of best fit, the height of a 50-year-old male should be 135 inches, which is over 11 feet. Why would that not be a valid prediction? Well, here's the issue. Line of best fit, it's a line. It means it goes forever. Now, the thing about that is people don't grow forever. At some point, they stop growing. And plus, have you ever really seen a person that's over 11 feet? It's impossible. So that would not be a valid predictor. This line of best fit is only valid for certain ages. After some point, you don't always grow. So eventually you're going to stop. Okay, it says, is the average male 28 inches when they are born? Why or why not? So we could go into this formula. When they are born, they are 0. So we would plug in 0 for the years. And it says 28.3, so if you round that, it's about 28 inches. So it says why or why not? We'll say yes, because that's what the line of best fit shows us when we plug that in. And that's reasonable. I mean, it would be weird if it said they were 0 inches, but 28 inches, that's what the data is saying. So we're going to go with it. And that's the review. So hopefully that helps you understand. This test should be relatively easy compared to the logs test. So hopefully you guys can pull off a better grade on that one.